So let's solve this question. This has been asked in GATE 2015. We have been given an equation with two numbers, both in different bases. One base is known and the other is unknown. And we have been asked to find the number of x comma y value pairs where y is one of the digits or one of the symbols of the number on the right hand side. Now in order to solve such questions where we are given two numbers in the form of an equation and the numbers are in different bases, the best approach, or I would say the only feasible approach, is to convert each number into the decimal number system and then proceed, because we are more accustomed to dealing with decimal numbers and it will make our task a lot simpler. So let's solve this. How do we convert a number into decimal number system? In order to convert a number into decimal number system, we take the sum of the positional weights. So let's see this. So I have 43 to the base x equal to y3 to the base 8. Now see, 3 is the LSB and it has a positional weight of 0. And 4 is the MSB having a positional weight of 1. So I take the sum of the positional weights and I write the digits, or I write the symbols from right to left, because the positional weights are increasing from right to left and it makes, or it reduces the chances of making any mistakes, any calculation mistakes. So I write 3 into x raised to the power of 0 plus 4 into x raised to the power of 1, which is same as 3 into 8 raised to the power of 0 plus y into 8 raised to the power of 1. Now if I solve these two expressions, I get 4x plus 3 equal to 8y plus 3, right? Because anything raised to the power of 0 is 1, so 3 into 1 will give me 3. 8 raised to the power of 1 is 8, multiplied by y gives me 8y. So I get 8y here, and here I get 4x. Yeah, let me just verify. So x raised to the power of 1 is x into 4 will give me 4x. X raised to the power of 0 is 1. 1 into 3 will give me 3. Okay. So I've got two values which are same on both sides of the equation. So I can simply cancel them out. And I'm left with 4x equal to 8y, which can further be simplified as x equal to 2y. So this is my equation. Now, starting from this equation, I have to derive the number of x comma y value pairs that are possible. Now, in order to go ahead with the derivation, or in order to find the number of xy value pairs, what I first need to do is I need to find the constraints that are existing on x and y due to this equation. Now, if you examine this equation closely, you will find that there are two constraints. The first constraint is x should be greater than 4. And let me write the constraints and I'll explain the reasons for me writing it. And the next one is y should be less than 8. Think about it. Let's just examine each constraint one by one. First one is x greater than 4. Now see, if I have a number in base x, the possible values that, or the possible symbols, I wouldn't say values, there are symbols making up a number system, right? For example, the decimal number system, which is of base 10, has 10 symbols starting from 0 going up to 9. So if I have a number system of base r, the possible values are 0 to r minus 1. If I have a number system in base r, the possible values are 0 to r minus 1, right? So using this expression or using this rule, we can say from this number, by looking at this number, we can say that x has to be greater than 4, because if it is not greater than 4, then it will not be able to accommodate this value 4, 3. If this base x has to accommodate this value 4, 3, if this value 4, 3 has to have some existence, has to have some real existence, then x must be greater than 4. So if it is greater than 4, only then I will have values starting from 0 till 4 or maybe even more. That's why I have x greater than 4. And now what about this? Applying this same rule, I can find out the constraint on y. See, the base is 8. That means the possible values that, or the possible symbols. By values I mean symbols, okay? So the possible values that this number system of base 8, which is an octal number system, can accommodate are 0 to 7. The base is 8, the bases are 0 to r minus 1. So 0 to 7. 8 minus 1, 7, r minus 1. Okay? So I hope you understood the relation between these two. So y has to be less than 8. If it is 8, it won't be possible because the possible values that can be accommodated by the radix 8 are 0 to 7. So it has to be less than 8, right? So if it is less than 8, then we have two constraints with us. Now, using the equation and the two given constraints, we can find the possible value pairs quite easily. See, if x has to be greater than 4, right? See, x has to be greater than 4. So if x has to be greater than 4, let me start with 5. If x is 5, and mind you, x has to be an even number as well, right? X has to be an even number as well. Why? Because x is equal to twice of the value of y. So whatever be the value of y, whether it is odd or even, if you multiply it by 2, you'll get an even number, right? And that will be the value of x. So x is always even. Now if x always has to be even, then 5 cannot be allowed. And as it is, y is my independent variable, x is my dependent variable. X is depending on y in order for its existence. So I can start by giving values to y. So what are the possible values that y can take? Y can take values starting from 0 till 7. So I'll just list them out one by one. 0, 1, 2, 3, 4, 5, 6 and 7. And let's see if x can take in the double of these values of y. So if can y be 0? Can y be 0? If y is 0, then x will come to be 0. Is this pair possible? It's not possible. Why? Because x has to be greater than 4. So this is rejected. Now if y is 1, x will be 2. See, if y is 1, 2 into 1 is 2, so x will become 2. Is this possible? No, because x has to be greater than 4. So this is discarded again. Now see, if y is 2, then x becomes 4. 2 into 2, 4. Is this allowed? No, because it has to be greater than 4. See, x has to be greater than 4, but it is equal to 4. So once again, it's rejected. Now look at this one. If y is equal to 3, then x will be 6. Is this allowed? Yes, see, all my constraints are being satisfied now. So this is very much allowed. Now if y is 4, x will come to be 8. Is this allowed? Yes, once again, why not? X has to be greater than 4. It's 8 in this case. Y is 4, which is less than 8, and even this equation is satisfied. So allowed. Now if y is equal to 5, x will come to be 10. Once again, it is allowed. Y is equal to 6, x will come to be 12. See, y is equal to 6, 2 into 6 is 12. So I get x is 12, which is greater than 4. So this is allowed. And what about this last one? If y is equal to 7, then x will come to be 14, which satisfies both these constraints as well as the equation. So this is also taken. So I get a total of 5 value pairs, right? I get a total of 5 x comma y value pairs. 5 x comma y value pairs, right? So I get total of 5 x comma y value pairs. So I hope this helps. Thank you.